right? So see, since the last class we are seeing about the manufacturing of iron. Okay, so we have seen about the different types of furnaces like cupola furnace, puddling furnace. Okay, and we have also seen the blast furnace. Okay, these are used for the manufacturing of iron and steel, etc. So now in this class we are going to see how we are going to manufacture the steel. And we do know that from pig iron, okay, by oxidizing the impurities, okay, depending upon the nature of slag produced, there are two types of processes for steel. Okay, so steel can be made, okay, or steel is made from pig iron, okay, so by oxidizing the impurities only. So this principle you have seen in the last puddling furnace also. So steel is also manufactured from pig iron only by oxidizing the impurities. So what are the two different kinds of processes depending upon the nature of slag that is going to be produced is, so one is acid steel making, and the another one is basic steel making. Acid steel making, and the other one is basic steel making. So right, so the type of processors that are going to be operated, so okay, so all these all depend upon only the raw materials. So whatever the processors are going to be operated, so whatever the things we are going to give the operations, so those are all going to be depend on the raw materials only. So if pig iron is low in sulfur and phosphorus, okay, so what is going to happen, the acid process is used and the slag is required to retain only the silica and manganese oxide. So if the pig iron that is we are using is low in the sulfur and phosphorus, then we are going for acidic processes. So what here is done being means that this acid process will use the slag, so that is required to retain only the silica and manganese oxide. So hence the furnaces lining, okay, that will be in contact with the slag, okay, or is made of acid refractory material. So by this we are going to, okay, produce the steel by acid steel making. So what is meant by basic steel making? So the basic process used to remove sulfur and phosphorus, okay, so besides the other impurities, if the sulfur and phosphorus are being removed, okay, then in this case the furnace lining is in contact with the slag is made of basic refractory materials. Okay, the basic refractory materials are going to be contact with this kind of impurities, then such a to eliminate the dolomite or magnesite, then we can say this is a basic steel making method. So both are okay, acidic steel making, okay, so basic steel making. So we should remember that when this for acidic steel making, okay, the sulfur, the phosphorus, and the acid, okay, so that is going to be used as slag, and to it is also required to retain the silica and manganese oxide. Hence, the furnace lining is in contact with the slag. So yes, the factory materials. Okay. So in the same way, if the impurities like sulfur and phosphorus are to be removed, okay, in this case of furnaces lining, that will be in contact with the slag and the refractory materials such as dolomite and magnesite. So here, if you are using the refractory materials like slag, okay, phosphorus, okay, and okay, manganese oxide, then that is called as acid steel making. Whereas basic refractory materials like dolomite or magnesite, if you are using, that is a basic process. So both this acid and basic processor are operated in the same converter, that is Bensmer converter. Okay, Bensmer converter. So the open heart, okay, the electric furnace, and we know that the greatest amount of steel is made by basic open heart process only. So with this regardless, this method is used for production of steel. Okay, and here there are two types of productions are going involved, two or three. So the first one is that removal of undesirable impurities. So the next one is the connecting the carbon content to the specified value. Okay, and the third one is the addition, if required, we have to add the alloying elements also. Okay, so this is the main principles of steel making. How many kinds we are going to manufacture steel? Two types. One is acid steel making. Next one is basic steel making. In acid steel making, so what we are using pig iron. Okay, if it is low in sulfur and phosphorus, then the acid is used, and the slag is required to retain only the silica and manganese. If we are if the acid is added, okay, and the slag is required to retain only in silica and manganese oxide, then the furnace's lining will be in contact with the slag, okay, to produce the refractory materials. If the basic process is that the beside all the impurities, okay, beside all the removal of sulfur and phosphorus, uh, the the furnace lining will be in contact with the slag, and that is going to made of basic refractory materials such as dolomite and magnesite. If you are adding dolomite and magnesite, that is called as a basic processes of steel making, right? So these are the two main processes involved in it. One is basic one and one is acid one, and the basic acid and the basic process are operated in the same converter, that is Besmet converter. Okay, the open heart and the electric furnace are also there. Okay, but the greatest amount of steel is made by basic open heart process. Okay, basic open heart process only. So this involves the removal of undesirable impurities, one, and the second one is that correcting the carbon content to a specified value, and the third one is that addition of these alloying elements. So these three are mainly involved here, right? So we are going to now watch one video regarding this manufacturing of steel and some of the things involved in the steel manufacturing. Okay.
PTP is inserted into tap hole for slag-free tapping. Lime is charged inside the empty furnace. Steel is made in basic oxygen furnace. This video is showing 3D animation of steel making process.
So steel making process, okay, animation we are going to see here. Okay, please do watch it.
At first step, lime is charged inside the empty furnace.
So the lime is charged inside the empty furnace. Okay.
Then the furnace is rocked to spread lime evenly.
సో ఈవెన్ గా స్ప్రెడ్ చేసుకోవడానికి ఫర్నెస్ అనేది దాన్ని రొటేట్ చేస్తున్నారండి, సచ్ దట్ ది లైమ్ విల్ బి ఈక్వల్లీ డిస్ట్రిబ్యూటెడ్ ఇన్ ఆల్ ద డైరెక్షన్స్.
PTP is inserted into tap hole for slag-free tapping. Scrap generated in mills, recycled and charged
సో ఏదైతే స్క్రాప్ మనకి ఇండస్ట్రీస్ నుంచి వచ్చేస్తుందో ఆ స్క్రాప్ ని ఏం చేస్తున్నారు, సో ఆ ఫర్నెసెస్ లో యాడ్ చేస్తున్నారు చూడండి.
into the furnace. Charging liquid iron, received from blast furnace.
సో మనం లాస్ట్ క్లాసెస్ లో ఐరన్ యొక్క మ్యానుఫ్యాక్చరింగ్ చూసుకుంటా వచ్చాం. సో బ్లాస్ట్ ఫర్నెస్ లో మనం పిగ్ ఐరన్ యూజ్ చేస్తాం కదా చెప్పాం కదండి. సో అక్కడ నుంచి తీసుకొచ్చిన ఐరన్ ని కూడా సో వీఆర్ గోయింగ్ టు యూజ్ ఇన్ దిస్ ఫర్నెస్. It will be in molten stage, okay, so that's why it is in say liquid stage, okay, right. That we will call it as charged liquid iron also.
Furnace is made vertically upright position and then blowing started by lowering oxygen lamps.
సో బ్లోయింగ్ అనేది స్టార్ట్ చేస్తున్నారండి. సో అప్పుడు ఏమవుతుంది అంటే కనుక పైన హాట్ గ్యాసెస్, ఓకే, ఆక్సిజన్ గ్యాసెస్ అవన్నీ పాస్ అయ్యి సో మనకు కావాల్సినటువంటి స్టీల్ అనేది స్లాగ్ తర్వాత ప్రొడ్యూస్ అవుతుంది.
After 16 to 17 minutes blow terminated by lifting oxygen lance.
సో బ్లోయింగ్ ఆఫ్ చేస్తారండి, ఆక్సిజన్ ల్యాండింగ్ కూడా ఆఫ్ అయిపోతుంది. ఓకే,
Slag generated by blowing process dumped into a slag pot.
సో స్లాగ్ ఏదైతే ఉందో అది స్లాగ్ పాట్ లోకి వచ్చేస్తుంది చూడండి. వేస్ట్ మెటీరియల్ we call it as slag, right? So this is we call it as dumping of slag also. The yellow material is called slag, we can say. Okay,
Temperature and samples are taken.
so after that collecting of slag we'll keep these temperatures, okay, and to maintain some of the temperatures, okay, after some temperatures what we,
Steel then tapped into a ladle.
so then we will get the steel, that is we call it as tapping, okay, tapping antaru. So we are going to collect the steel. సో ఫెర్రో అలాయ్స్ కూడా యాడ్ చేస్తున్నాం చూడండి అండి, ఎడిషన్స్ ఆఫ్ ఫెర్రో అలాయ్స్ ఆల్సో. సో స్టీల్ ఈజ్ ఆల్సో మిక్చర్ ఆఫ్ ferrous materials.
Slag stopper is applied to ensure slag-free tapping.
సో ఈ మనము స్టీల్ కలెక్ట్ చేసేటప్పుడు ఏమన్నా కనుక మనకి స్లాగ్ వస్తుందేమో అని చెప్పి స్లాగ్ స్టాపర్ కూడా మనకి యాడ్ చేస్తారు, అప్పుడు స్లాగ్ అనేది అక్కడ ఆగిపోతుంది. ఓకే,
Tapping ends and liquid steel is rinsed with argon gas.
సో ఆర్గాన్ గ్యాస్ తో రిన్స్ చేస్తారండి. ఓకే, then this is the steel that is produced from the furnace, right? సో నైట్రోజన్ స్లాగ్ స్ప్లాషింగ్ కూడా జరుగుతుందండి. ఓకే, so why we are adding this nitrogen slag splashing means if there are any other materials or if there is slag remaining in the furnace, so to overcome that, so we will add this nitrogen pellets to it. Okay, splashing will do it.
Remaining slag is dumped into slag pot.
If there is any remaining slag, then we can so it will be dropping into that slag box.
The furnace is ready for charging again.
So then after removing of all the slag, then the furnace will get ready for the next one, right? So yes, I think you are clear by this. Okay, so yes, we'll watch one more video regarding this steel making. Okay,
Blue one is mainly for cabbage. First thing, you can go one way like this, but once you get hang of it, you just simply go backwards and forward, and it's
such as the Americas and Australia. The mining involves using explosives to break up. How is steel made? How do we produce enough heat to melt it? How do we get molten steel into a form that we can use, and what is the best way of doing this?
so regarding the steel, there are many questions that which raises for us daily. Okay, so some of the questions like where we are using this, what
How is steel made? How do we produce enough heat to melt
సో ఎంత ఎనర్జీ కావాలి, లేకపోతే ఎంత హీట్ కావాలి దాన్ని మెల్ట్ చేయడానికి.
it? How do we get molten steel into a form that we can use, and what is the
మెల్ట్ అండ్ స్టీల్ ని మనం ఎట్లాగా యూజ్ చేసుకోగలం?
best way of doing
ఓకే, అండ్ వాట్ ఇస్ ద బెస్ట్ వే? సో ఏ మెథడ్ యూజ్ చేసి మనం స్టీల్ ప్రొడ్యూస్ చేయగలము? ఇట్లా దెర్ ఆర్ డిఫరెంట్ క్వశ్చన్స్ ఫర్ us that which raises when we are seeing about the steel manufacturing, right?
this? In this module, we will try to answer these questions by looking at iron ore, blast and electric arc furnaces, steel making and casting. We also reveal how many Eiffel Towers.
See, we have already seen in the last classes regarding the cast iron production. So first part will be that, and after that we will see about this iron also, steel also. Okay, please do.
We could make in an hour from the world's steel production. Iron ore is common in the Earth's crust and contains iron chemically bonded to oxygen. It is mined in areas such as the Americas and Australia. The mining involves using explosives to break up rock. This is then crushed and the iron ore separated from non-metals. Iron ores from different locations are blended together. This is combined with coke and heated to make an iron-rich feedstock for the blast furnace called sinter. Sinter is added to
So these are all the things involved in the making of cast iron. Okay, so we have already seen this one. So a couple of furnace, blast furnace, electric arc furnace, we have seen all this. Okay, so just I'm leaving this.
the blast furnace along with coke and lime, and a continuous hot air blast is injected through nozzles called tuyères in the base of the furnace. This air blast, from which the process gets its name, helps raise the temperature of the furnace to 2,200 degrees Celsius or 4,000 degrees Fahrenheit. This is high enough to cause the chemical reduction of the iron oxide from the sinter, carbon added as coke and oxygen from the hot air blast into molten iron and carbon dioxide. The lime forms with the impurities to form a liquid called slag, which floats on the iron. The liquid iron collects in the bottom of the blast furnace, where it is drawn off, and the slag is skimmed off and used in other industries, like cement manufacture. Making iron in
So slag we are going to use in cement manufacturings also, and this iron we will use for castings and all other things which are involved for us.
a blast furnace is a continuous process, and they often run for many years at a time. The metallic iron produced in a blast furnace contains substantial amounts of impurities such as sulfur, phosphorus, and silicon. These impurities make the iron virtually useless without
So by this metals, okay, so if the iron oxide is containing about the sulfur, phosphorus, and silicon, then we can say that it is having a very high slag rate. Okay, so that is
Without further processing. Basic oxygen steelmaking is the main batch production process for refining iron from the blast furnace into steel and accounts for approximately 1,200 megatons per year. This is enough steel to make nearly 19 Eiffel Towers every hour. In the basic oxygen steelmaking process, 300 to 350 tons of iron can be converted into steel in approximately 30 minutes. First, scrap steel is put into the vessel, then the molten iron is added. A lance
so first we are going our scrap steel and molten metal is added to it. Okay,
blows high purity oxygen onto the iron
and
at
we are passing the high purity oxygen to that. Okay,
approximately twice the speed of sound. This causes the rapid oxidation of carbon, manganese, and silicon in the charge. These
so అది ఆక్సిజన్ అనేది వెరీ హై ఇంటెన్సిటీతో పాస్ చేసేటప్పుడు ఈ కార్బన్, మెగ్నీషియం, సిలికాన్స్ ఏవైతే ఉంటాయో అవి సో ఫాస్ట్ గా డిగ్రేడ్ అయ్యేటట్టు చూస్తుంది.
reactions, which give off heat, help to melt the scrap and aid in the refining
Carbon,
process.
magnesium, silicon will
The impurities in the metal are removed by oxidation and interaction with
okay melted. Okay, and these impurities in the metals are removed by oxidations, and the slag will get interacted to that oxidation metal.
the slag. The steel is then processed further in secondary steel making. Before we look at secondary steel making, another process for producing steel is the electric arc furnace. The
So we can also use electric arc furnace also for producing of steel. Okay, the
electric arc furnace accounts for the majority of the remaining steel production and produces around 400 megatons per year worldwide. That's the equivalent of melting down one Titanic every hour. In comparison with basic oxygen steel making, the electric arc furnace has the advantage of being able to start with a solid charge, as it does not use iron from the blast furnace but uses cold steel scrap, making
we
it
have also seen about this electric arc furnace. Okay, so అదేంటంటే మోల్టన్ మెటల్ ఏం తీసుకుంటుందండి, డైరెక్ట్ గా ది సాలిడ్ స్టీల్ స్క్రాప్ ఏదైతే ఉంటుందో దాన్నే అది హీట్ చేస్తుంది.
one of the world's largest recycling processes. The electric arc furnace makes a steel batch up to 150 tons in under 1 hour, and the process permits extremely close control over temperature, composition, and refining conditions for each heat, making it particularly useful for specialty steels like stainless steel. The furnace is filled with steel scrap. The furnace lid is swung into place, and 3 graphite electrodes are lowered into the furnace. A powerful electric current is passed through the electrodes, creating an arc. The arc reaches temperatures of about 12,000 degrees Celsius or 21,500 degrees Fahrenheit. This is twice the temperature of the surface of the sun, and consequently, the heat generated melts the steel scrap. Once the first load of scrap is melted, a further 1 or 2 loads of scrap are added. Lime and fluorspar, a type of flux, are added, and oxygen is usually blown into the melt, causing impurities in the metal to combine and form a slag. The steel is monitored for composition and temperature, and then the steel is drawn off into a ladle and sent for secondary steel making. After basic oxygen steel making or the electric arc furnace, secondary steel making is used to further refine the steel. In secondary steel making, fine additions of alloys are made to meet the customer specification.
So to acquire different kinds of specifications or the things what the customer is going to acquire from us, okay, we will change the next process also. So we may shift to the next further process also, so that he is going to explain. Please do it.
Temperature is controlled and gases such as oxygen are removed through the addition of aluminium and silicon. The process also reduces impurities such as sulfur and phosphorus through slags that will be built up in the ladle. This slag also retains heat in the ladle and isolates the molten metal from the air. Following steel making, casting is required to solidify the molten steel ready for shaping or forming into a suitable
So
profile.
before going to steel making, we should also know about the cast iron making and iron manufacturing also. For that, he gave the clarification.
The three main ways of doing this are sand casting, continuous casting, and ingot casting. Sand casting. Sand casting is a process for making a part by pouring molten metal into a mold, having a cavity of the desired shape, and then allowing it to solidify. In sand casting, sand mixed with water and suitable binders is the molding material. The mold
So sand casting plus sand plus water mix ayi. So we used to pass it with a high force. Okay. So
molding material is packed around a pattern often made of wood. This pattern is slightly larger than the finished part due to the contraction of the metal on solidification and cooling. When the pattern is removed from the molding material, a cavity having the same shape as the pattern remains. The sand must be packed or rammed to the correct degree to avoid air or water vapor being trapped in the molten metal, causing unsoundness. The cavity is usually created in 2 or more sections that are then fitted together to create a mold. The mold will have 1 or multiple holes in which to pour the molten metal. There will be channels to direct the molten metal, and there will also be a reservoir next to the cavity, so that when the molten metal in the cavity solidifies and consequently shrinks, any voids will be immediately filled with more molten metal from this reservoir. Metal of the desired composition is heated well above its melting point in order to ensure good fluidity. If this is not done, the molten metal may solidify in the mold and consequently be unable to completely fill up. Many casting grades of steel have higher levels of silicon, as this helps to increase the fluidity of the molten metal. After the metal has solidified, the finished casting can be shaken or knocked out of the mold, which can only be used once. The advantages of sand castings include low cost, high flexibility, virtually any sized casting can be produced, and it is a simple, expedient way to make a wide range of products. Continuous casting. Usually, continuous casting uses feedstock from the basic oxygen steel process. A ladle of steel is teamed or poured through a gas-tight refractory nozzle into a ton dish with special weirs and dams to aid in the removal of impurities. This ton dish is a reservoir, and it feeds the steel through further gas-tight nozzles into a number of water-cooled copper molds. The cooling is controlled and only the outer skin of the steel is solidified. The molds are oscillated to ensure that the solidifying shell does not stick and break. Flux is also added to aid lubrication. The steel shell grows as it is drawn down through a curved arrangement of support rolls and water sprays. It then emerges horizontally as solid steel strands and is cut to length with automatic gas burners. Depending on the size, these solid strands are called billets, blooms, or slabs. The billet, blooms, and slabs are normally processed through a rolling mill where the cast structure is refined. Initial setup of a continuous caster is expensive, but it is a very efficient process, has an excellent throughput, and has yield benefits over other types of casting. Ingot casting. Ingot casting is primarily used with the electric arc furnace, and as with continuous casting, it is an intermediate process to solidify steel to enable further shaping, primarily in a forge or rolling mill. It is a process where molten steel is poured into a cast iron ingot mold, often cylindrical in shape. The finished ingots can weigh anything from a few kilos to hundreds of tons. The main ways of casting these ingots are either uphill teaming or vacuum casting. Ingots that are uphill teamed use a ladle either directly or in a teaming car that is positioned over a feeder system to enable the ingots to be filled from the bottom of the mold. The ladle is positioned over a funnel called a trumpet. It is opened and the metal stream established. The pouring rate is controlled throughout this teaming process. Powders which have an exothermic reaction are often added to the top of the ingot following teaming to generate heat to aid in the feeding of the ingot, minimizing voids cool pipe. Insulating material is also added to aid in this. For ingots that are vacuum cast, the mold is placed in a vacuum tank and an intermediate ladle is positioned on top. The ladle that is on the vacuum tank is filled with molten metal and the tank's pressure is pumped down to create a vacuum. Pouring of the ingot is started and the intermediate ladle is fed with additional molten metal if required. The ingot is filled, the pressure vented, and the same exothermic and insulating powders are added to reduce voids in the ingot-cooled pipe. Although these powders are added, some porosity and vacancies will form within the material due to
So however, we are going to manufacture about this. So there will be definitely the holes or voids or different gaps in between the centers. So see,
shrinkage and gases liberated from the operation. A large feeding pipe defect is cut from the ingot, but most porosity in the ingot is acceptable since it will disappear through further processing in the rolling mills or forge. In both continuous and ingot casting, the metal solidifies from the outside, progressing towards the center, and thus the ingot's grain structure develops as columnar and points in the direction of solidification. This grain structure development is typical of cast materials. Hot rolling or forging will break up the cast structure and form a smaller, more uniform wrought grain structure. Ingot casting is better suited to one-offs and small batches. It is also able to produce large ingots easily and is the least complicated of the casting techniques. So in summary, the majority of steel is processed through the blast furnace, basic oxygen steel making, secondary steel making, and continuous cast process. The electric arc furnace is more versatile for small batches and is very well suited to specialty steels like stainless steels. Secondary steel making refines the steel and controls parameters to meet the customer specification. The advantages of sand casting include low cost, high flexibility, virtually any size casting can be produced, and it is a simple, expedient way to make a wide range of products. Ingot casting is used primarily with the electric arc furnace and is best suited for one-offs and small batches. It is also able to produce large ingots easily and is the least complicated of the casting techniques. Continuous cast and ingot cast materials are further worked in a rolling mill or forge to refine the structure, whereas sand castings are not.
right, is it clear to all? Okay, then we'll move to the next one. That is the Bessemer convector, right? So Bessemer convector. So this is it is a process. So what is the process is going to happen is that the steel making will be done in this Bessemer convector. So you can see this. Yes. So rolls and all this. Okay, wait a second. I will just. Right. This is our so the second part, that is Bessemer convector, right? So what are the main things happening here, and how we are going to composite our iron? Okay, sorry. Yes, pig iron into steels, right? So we'll see this today. Yes, remaining 20 minutes we are going to look about this Bessemer convector. So shall I move on? Yes, is there any clarifications or doubts from my side? To clarify from your side, please. Any clarifications, or shall I get continued? Yeah, you can type in your chat, or you can write in your box, answer box, right? Or you can raise your hand. Sure. I will I will give, I will forward notes. Okay. Yes. Okay, right. So I will move on to this Bessemer convector. So this Bessemer convector process of steel making was introduced by Henry Bessemer in 1857. So this process consists of refining the molten pig iron in a converter. So the name itself says that it is a converter. So Bessemer converter is it is a process consisting of refining molten pig iron in a converter. So the body of the converter is made of steel plates, right? And is lined with silica bricks. Okay, steel plates and also lined with silica bricks. The top of the convector is open, so the top will be in open condition, open way. So the bottom contains the tires and a wind box to equalize the air pressure at all the tires. So as we have seen our first furnace, that is our blast furnace. So this is also containing the tires, and also opened at yes, it is open at top end, and bottom where containing tires, and a wind box is also there to equalize the air pressures at all the tires, right? A hollow pivot or a tunanion enables the convector that such that it makes it to rotate in three positions. Okay, so that means what are the three positions? Loading or charging. So ఇందాక మనం చూసామండి వీడియోలో. సో మనకున్న ఫర్నెస్ అనేది 3 డైరెక్షన్స్ లో మూవ్ అయింది. సో 3 వేస్. సో అవేంటి 3 పొజిషన్స్ ఏమేంటంటే లోడింగ్, ఫస్ట్ వన్ ఈస్ ద లోడింగ్ ఆర్ ఛార్జింగ్. సో ఫస్ట్ మనం లోడ్ చేయడం కానీ చార్జ్ చేయడం కానీ అంటామండి. దాన్ని ఏంటంటే ది కన్వర్టర్ ఈజ్ రొటేటెడ్ టు హారిజాంటల్ పొజిషన్ టు రిసీవ్ ది ఛార్జ్. ఓకే, సో ఛార్జ్ రిసీవ్ చేసుకోవడానికి సో ది కన్వర్టర్ ఈజ్ గోయింగ్ టు బి రొటేటెడ్ టు ది హారిజాంటల్ పొజిషన్. సో వర్టికల్ గా ఉన్న పొజిషన్. ఓకే, సో ఫర్ ఎగ్జాంపుల్ దిస్ ఇస్ వర్టికల్ పొజిషన్, రైట్? సో ఇట్ గెట్స్ moved to horizontal direction to get charged. Okay, so to receive the charge, so the what we call the convector moves in a horizontal direction such that the charging or the loading position is going to be received. So this is the first one. Second one is blowing. First one is charging or loading or charging. Second one is blowing. So what happens in blowing? In blowing, the upright position when the blast of air is forced through it, so it will change its position to the right one. So in this direction it is going to change. So okay, so what happen for the blast of air is forced. So with this direction, the blast of force. Okay, so blast of force is going to be placed here. Okay, so then the next one, that is the third one, that is pouring. So pouring, what happens? It converts its rotated molten steel into the ladle. So for ladding, so ladle lo మనం pour చేయడానికి మళ్ళీ ఇది ఈ డైరెక్షన్ లో తిరుగుతుంది. ఓకే, సో అది మనం గుర్తుపెట్టుకోవాలి. సో దీస్ ఆర్ ద త్రీ మెయిన్ పొజిషన్స్ దట్ విచ్ వీఆర్ గోయింగ్ టు సీ ఇన్ Bessemer converter. One is charging or loading. So what the converter do, it rotates to a horizontal position to receive the charge. So for receiving of the charge, so the converter, okay, rotates horizontal position. So that is called charging or loading, right? So the second one is blowing. So the upright position will be obtained when the blast of air is forced through it. I think it may be in upright position. Okay, so that means in the upward position. Okay, it acquires backward position. Okay, to get the air, okay, air with a force of blast. So that is called blowing. And the third one, that is pouring. So pouring, what the converter will do, it rotates. Okay, so and after rotating, it will get rotated to other direction, that may be right or left, to give the molten steel into the ladle. That is pouring. So to give the molten steel into the ladle, so rotating, yes, first one charging, the next one blowing, and third one pouring. The last one, pouring, is going to take place for the ladle to collect the steel metal, right? So this is the main thing that is happening in the Bessemer converter, right? Okay, yes, I will. So then the composition of pig iron for this processes, how it is going to be, and what are the things that which we are seeing here. See, yes, about the furnace we have seen. Bessemer converter we have to see. So this is a Bessemer converter. Okay, so it contains all the things like what are the air, okay, lining, okay, and shell, and Turanian, okay, and blast pipe, tires. Okay, so these are the tires here. So these things are the tires. Okay, and air also will be there to enter inside it. Okay, and these are the things that are required for the Bessemer converter, right? So then we'll move to the composition of pig iron, right? So what is this composition of pig iron? For this process we will see, and this operation of blast converter also we are going to see. So this is called blast converter, right? So we should keep in mind that what is the Bessemer converter. Okay, so converter, right? So the slag produced in the acid Bessemer, okay, processes is acidic in charge, okay, in character. So that means the slag that is going to be produced in the acid Bessemer process is acid in character. That is what the sulfur, the phosphorus. Okay, so that will be in original pig iron. Okay, in the original pig iron, okay, are therefore not reducted at all. So this will not be reducted in the original pig iron. So the pig iron used here should not be high in these elements. Okay, so what was the thing is that the pig iron that is which we are going to use here should not have the high of these elements like phosphorus or sulfur, etc., right? And acid Bessemer, okay, so in the pig iron should therefore have the following composition. So what is the composition? That means carbon. So carbon ఎంత ఉండాలండి? 3.5 to 4.3% ఉండాలి. Okay, and silicon. So silicon is that 2.0 to 2.5% ఉండాలి. And our manganese, so ఎంత ఉండాలి? 0.75 to, okay, 1% ఉండొచ్చు. Okay, then sulfur and phosphorus అనేది రెండు మిక్చర్ లో 0.04 to 0.05% ఉండొచ్చు, mixture of the sulfur and the phosphorus. So this is the main compositions of our required pig iron. If the pig iron is not maintaining these kinds of compositions, then we can we might add some things to get acquired this one, or sometimes we will not consider this one. Okay, so right, so our operation of the Bessemer converter we will see here. In the Bessemer process, steel Okay, so how this steel is going to be produced? By oxidation. So by oxidation, this is in the Bessemer processes, the steel is going to be produced. So the impurities and carbon, by blowing the air through the molten pig iron, we are going to acquire that one. Okay, the process of commence by rotating. Okay, so what happens? The conductor, it gets rotated. Okay, to get the charging position, and pouring the molten pig iron into the conductor to the level adjusted, and then the tires level are to be maintained in it, and the then we can get rotated into the upright positions, and the blast of air is forced through the tires at a pressure of 2 to 2.5 bar. Okay, the blast of air helps to eliminate the impurities and carbon at 350 cubic meters, and the air requires per ton of pig iron. So 350 cubic meters of air is required per ton of pig iron. So pig iron first మనం ఏం చేస్తామంటే, ఓకే, సో ఫస్ట్ దాన్ని చార్జ్ చేసుకుంటామండి. బెస్మర్ కనెక్టర్ ని చార్జ్ చేసుకున్న తర్వాత, సో ఇంప్యూరిటీస్ లైక్ కార్బన్, ఓకే, బై బ్లోయింగ్ ఎయిర్ త్రూ ది మోల్టన్ పిగ్ ఇయర్, సో ఇవి యాడ్ చేస్తాము. ది ప్రాసెసెస్ కమన్స్ బై రొటేటింగ్ ది కన్వర్టర్ టు ఏ ఛార్జింగ్ పొజిషన్. సో ఫస్ట్ ఏం చేస్తాం, ఛార్జింగ్ పొజిషన్ లో పెట్టుకుంటాము, అండ్ వి పోర్ ది మోల్టన్ పిగ్ ఇయర్ ఇంటూ కన్వర్టర్. సెకండ్ ఏం చేస్తామంటే, మోల్టన్ పిగ్ ఇయర్ ని మనం ఈ కన్వర్టర్ లోకి వేసుకుంటూ టు ఏ లెవెల్ అడ్జస్టెడ్ బిలో ది టైరిస్ లెవెల్. సో టైరిస్ లెవెల్ కన్నా కొద్దిగా తక్కువ ఉండేంత వరకు కూడా మనం ఏం చేస్తాము, ఈ యొక్క పిగ్ ని దానిలో వేస్తాము. సో ఇట్ ఈస్ దెన్ రొటేటెడ్, ఓకే, ఇంటూ అన్ అప్రైట్ బ్లోయింగ్ పొజిషన్. అండ్ సో ఒక అప్రైట్ పొజిషన్ అంటే సమ్ ఇంక్లినేషన్ పొజిషన్ అనుకోవచ్చు. సో ఆ పొజిషన్ కి మనం తీసుకొచ్చిన తర్వాత, అండ్ బ్లాస్ట్ ఆఫ్ ఎయిర్ ఈస్ ఫోర్స్ త్రూ ది టైరీస్. సో ఒక పొజిషన్ కి వచ్చిన తర్వాత టైరీస్ నుంచి ఏమవుతుందంట, ఎయిర్ అనేది విత్ 2 to 2.5 బార్ ఆఫ్ ప్రెషర్ తో ఫాస్ట్ గా ఫోర్స్ అవుతుంది. సో దెన్ ది బ్లాస్ట్ ఆఫ్ ఎయిర్ helps to eliminate impurity. So ఈ ఎయిర్ ఎందుకని అట్లా బ్లాస్ట్ అవుతుందంటే, this gets useful, or this is useful to eliminate the impurities, okay, and carbon impurities and carbon. So ఎంత ఎయిర్ దీనికి సుమారుగా ఉంటుందంటే కనుక 350 cubic meter of air is required per ton of pig iron. So 350 cubic meters of air అనేది రిక్వైర్ అవుతుందండి. సో ఫర్ ఏ పిగ్ iron. So the oxygen of the blast oxides, okay, so the iron to the ferrous oxide ఎలా ఉంటుందంటే 2Fe plus O2 gives rise to 2FeO2. Here what is the equation to the oxidation of blast iron key? So 2Fe plus O2 gives rise to 2FeO2. 2Fe2FeO. Okay, so this is the equation for the ferrous oxide. So then the iron oxide then reacts with the impurities. Okay, so the iron oxide that is contained in the converter, that which will react with the impurities, the thus the elements like a silicon, magnesium and carbon are eliminated in the order indicated. Okay, so how in this in the regarded order, okay, in the mentioned order, like what is order, Si plus 2FeO, Si plus 2FeO, what it gives, 2Fe plus SiO2, 2Fe plus SiO2. So Si plus 2FeO gives rise to 2Fe plus SiO2. See here it is balanced, Si1, okay, oxygen here 2, okay, here also oxygen 2, and ferrous 2, 2Fe, right? It is get balanced. So by this by this reaction, what is going to eliminate? SiO2 is going to eliminate. Similarly, magnesium Mn plus 2Fe ferrous oxide gives rise to Fe ferrous, it will remain ferrous plus MnO. So this is the manganese oxide. So manganese is the slag here, or I can find it out. And also carbon plus FeO, what we are going to get, Fe plus CO. So these are the slags that which we are going to get here, right? And the next one is that, so the oxidation of these impurities provides the necessary heat for this process. So by this oxidation, the impurities that are going to be here provides the necessary heat for the process. So then the carbon escapes as a gas, while the silicon and magnesium along with any iron that may be oxidized in form of slag. So ఇవన్నీ కూడా slag లో ఉండిపోతాయి. కార్బన్ ఏమో గ్యాస్ కాబట్టి ఇది బయటకి వెళ్ళిపోతుంది, రైట్? So the refining sequence can be followed by appreciance of the flame at the mouth of the conductor. So we can see this mouth open చేస్తే కనుక ఈ కార్బన్ అనేది వెళ్ళిపోవడం చూస్తాం. Okay, during the earlier part of the blow, that is when the silicon manganese are being oxidized, the flame is short, okay, yellow in color and of low luminosity. So ఇప్పుడు మనం చూస్తే కనుక ఇక్కడ ఫ్లో ఇక్కడ ఎలా ఉంటుంది అక్కడ ఎలా ఉంటుంది అంటే కనుక yellowish కలర్ లో ఉందండి. సో దీన్ని బట్టి మనకి ఏం చెప్పొచ్చు అంటే కనుక due to this kind of flows there are, okay, so the color luminosity intensity we can obtain. Okay, yellow color అనేది అది ఏంటంట ఈ స్లాగ్ కి రిప్రజెంట్ చేస్తుంది. టువర్డ్స్ ది ఎండ్ ఆఫ్ ది స్లాగ్ ది కార్బన్ begins to oxidize and the flame charges in the catalyst, okay, and it becomes a white in color. Slag yellow, first yellow color lo ఉంటుంది, కాస్త white color లోకి వస్తుందండి. So then we can obtain that the white color increases the length of luminosity. When the decarbonization is completed, the flame drops, okay. So flame yellow color flame drop out ఎందుకంటే decarbonization, okay. So the blowing is discontinued at any propositions of this blowing after the drop of the flame, okay, what it is going to result in oxidation of iron, and this will increases the amount of brown fumes in the flame. At this stage the conductor is turned to horizontal plane. ఎప్పుడైతే బ్రౌన్ కలర్ ఫ్లేమ్ లోకి చేంజ్ అయిపోతా ఉందో మనకు అప్పుడు అర్థమవుతుందండి ఏంటంటే ఆ బ్లోయింగ్, ఓకే, prolongation of this blow చేయడం వల్ల flame results in oxidation and it indicates the amount of brown flame. Okay, ఇది ఎక్కువైపోవడం వల్ల మనకి ఆక్సిడేషన్ దాటిపోతుందని అర్థమవుతుంది, బ్రౌన్ ఫ్లేమ్ వస్తుందండి. సో అప్పుడు మనం ఆ కన్వర్టర్ ని ఏం చేస్తాము, మళ్ళీ రైట్ హారిజాంటల్ ప్లేన్ లోకి మార్చుకుంటాము. ఓకే, సో దాన్ని ఎయిర్ బ్లోయింగ్ ఈ స్టాప్, అప్పుడు ఎయిర్ బ్లోయింగ్ అనేది ఆగిపోతుంది. సో ది బ్రౌన్ మెటల్ ఈస్ జనరలీ లో ఇన్ కార్బన్ అండ్ కన్సిస్ట్ ఆఫ్ డిజాల్వ్డ్ గ్యాసెస్. సో ఈ బ్రౌన్ మెటల్ ఎలా చెప్పాము అంటే, సో దిస్ ఈస్ ఇట్ కంటైన్స్ ఆఫ్ డిజాల్వ్డ్ గ్యాసెస్ ఇన్ కార్బన్. ఓకే, అండ్ ఇన్ ఆర్డర్ టు మేక్ దిస్ మెటల్ సూటబుల్ ఫర్ కాస్టింగ్, సో దీన్ని మనం కాస్టింగ్ కి యూజ్ చేయాలంటే ఏం చేస్తామంటే ఇగ్నాట్స్ అనేది చేస్తాం. సో ఇంగోట్స్ మెథడ్ మనకి చూస్తూ వచ్చాం కదండి. సో ది రిక్వైర్డ్ అమౌంట్ ఆఫ్ కార్బన్ ఈస్ నౌ యాడెడ్ ఇన్ ఫార్మ్ ఆఫ్ ఓకే స్పెసిఫికన్స్ లాగా యాక్ట్ చేస్తాము. 10 to 35% మ్యాంగనీస్ కార్బన్ ఉన్నది, ఆర్ ఫెర్రో మ్యాంగనీస్ కూడా యాక్ట్ చేస్తామండి, 78% ఇది. సో ఇప్పుడు అల్యూమినియం ఈస్ యాడెడ్ టు ది మెటల్, ఓకే, టు ఎలిమినేట్ ది ఆక్సిజన్. Okay, this additives bring the manganese, silicon, carbon content of steel as specified values. So after rocking these vessels twice, the slag is removed, and it is possible therefore this pouring of metal into the other ladding. So the వీటన్నిటిని కూడా మనం ఏం చేస్తామండి, ladders లో తీసుకువెళ్ళి మనం కావాల్సిన స్టీల్ ని యూజ్ చేసుకుంటాం. సో ఛార్జింగ్ పొజిషన్ ఎలా ఉండాలి, స్లోయింగ్ పొజిషన్ ఎలా ఉండాలి, pouring పొజిషన్ ఎలా ఉండాలి అనేది you can see here, this is pouring position. Okay, so this is pouring position, ఇది pouring position అండి. సో తర్వాత మనకి స్లోయింగ్ పొజిషన్ ఒకటి ఉంటుంది, స్లోయింగ్ అని. సో బ్లోయింగ్ పొజిషన్ ఇది బ్లోయింగ్, అండ్ pouring పొజిషన్ కూడా pouring is there na, right. సో రైట్, సో ఛార్జింగ్ పొజిషన్ ఎట్లా ఉంటుందంటే ఇట్లా ఉంటుందండి. సో ఫర్ ఎగ్జాంపుల్ దిస్ ఇస్ ద కన్వర్టర్ ఇఫ్ యూ థింక్, ఓకే, ఇట్లా ఉంటుందండి. సో ఈ పొజిషన్ లో ఉంటుంది. సో మనకున్న మెటల్ ఇట్లా ఉంటుందండి. ఓకే, దెన్ దిస్ ఇస్ కాల్డ్ యాజ్ ఛార్జింగ్ పొజిషన్. సో ఇక్కడ ఒక చుట్టూ ఇది ఉంటుంది. ఓకే, దెన్ దిస్ ఇస్ కాల్డ్ యాజ్ ద pouring charging position, charging. Okay, right, I think you are all clear with this charging and slowing and pouring positions. Okay, so yes, if you are having any doubts, please feel free to express it, and we will close this. సో యూజ్ ఆఫ్ యాసిడ్ బిస్మత్ స్టీల్ గురించి చూద్దామండి. సో యాసిడ్ బిస్మత్ స్టీల్స్, ఓకే, పొసెసెస్ గుడ్ వెల్డబిలిటీ. సో ఇక్కడ నుంచి తయారైన స్టీల్ అనేది ఎలా ఉంటుంది అంటే దిస్ ఇస్ హావింగ్ గుడ్ వెల్డబిలిటీ, దిస్ ఇస్ హావింగ్ గుడ్ మిషనబిలిటీ. ఓకే, సో మిషన్ చేయడానికి ఈజీగా, వెల్డ్ చేయడానికి ఈజీగా ఉంటాయి. అండ్ దీస్ ఆర్ హ్యావింగ్ గుడ్ రెసిస్టెన్స్, వేర్ రెసిస్టెన్స్, ఎక్కువ తొందరగా తుప్పు పట్టవు, ఎక్కువ కాలం మన్నికి ఉండేలాగా ఉంటాయి. బట్ పొసెసెస్ పూర్ ప్లాస్టిసిటీ. సో ప్లాస్టిక్ నేచర్, ఎలాస్టిక్ నేచర్ అనేది ఉండదు. It is suitable for rails, okay, where resistance to wear is desired. So rails లో రైల్వేస్ లో ఎక్కువ యూజ్ చేస్తారు, ట్రాక్స్ లో కానీ రైల్ కన్స్ట్రక్షన్స్ లో కానీ. ఎందుకంటే టు అక్వైర్ ది గుడ్ వేర్ ఓకే సో వేర్ ఎక్కువగా ఉన్నది కాబట్టి వేర్ రెసిస్టెన్స్ కాబట్టి అండ్ ఇట్ ఈస్ ఆల్సో ఎంప్లాయిడ్ ఫర్ యాక్సిల్స్. సో ఏదైతే మనకి కార్ యాక్సిల్స్ లో కానీ ట్రక్స్ యాక్సిల్స్ యూస్ చేస్తారు కదండి, సో అక్కడ యూస్ చేస్తారు, స్ప్రింగ్స్ దగ్గర యూస్ చేస్తారు. సో సమ్ వైర్స్, సమ్ సాస్, సమ్ బోల్ట్స్ అండ్ నట్స్ అండ్ వెల్డెడ్ ట్యూబ్స్ దగ్గర కూడా ఈ యొక్క ఐరన్ అనేది యూస్ చేస్తారు. ఓకే సో దిస్ వాస్ అబౌట్ దిస్ ఆల్ steels. Okay so Bessemer convector also we have studied. Okay so some of the important points. Okay, on a summary, we have seen about the principles of steel making, acid steel making and basic steel making, and some of the methods for production. Steel involves removal of undesirable impurities, correction of carbon contents to a specific value, addition of steel alloys we have seen, and we have seen about the Bessemer convector process. Okay సో లాడిల్ ఏంటి, బ్లోయింగ్ ఏంటి, పౌరింగ్ ఏంటి, ఛార్జింగ్ ఏంటి చూసాము, కాంపోజిషన్స్ చూసాము, ఎలాగ బెస్మర్ కన్వర్టర్ కాంపోజిట్స్ స్లాగ్ ని ఎలా వేరే చేస్తుందని, అండ్ పొజిషన్స్, ఛార్జింగ్ పొజిషన్స్, స్లోయింగ్ పొజిషన్స్ కూడా, పౌరింగ్ పొజిషన్ కూడా మనం చూసాము. ఓకే విత్ దిస్ వీఆర్ గోయింగ్ టు స్టాప్ అవర్ క్లాస్ ఫర్ టుడే అండ్ టుమారో వీ విల్ జాయిన్ వన్స్ అగైన్ విత్ ద న్యూ టాపిక్. ఓకే సో థ్యాంక్ యూ once again.
Isn't it?